In this video, I am going to go over how to solve the Flair Furniture Company problem and also a example homework problem from Connect so that you can see what you would do as you approach the problems in Connect because they're just displayed a little bit differently. Hopefully, you have taken advantage of my suggestion at the end of the last video and attempted to solve this on your own, because that's really where the learning is going to happen, is to kind of stumble through, figure out, well, what am I doing wrong, and being able to solve it. And then this video will just give you that, hopefully, that confidence that you did it correctly. Okay, so we have here Flair Furniture Company that makes two products, chairs and tables. And they're trying to decide how much of each product should they make this month in order to maximize their profit. And we have some constraints for each type of carpentry and painting that would go into the making of a table and a chair. So for carpentry, there's 3 hours for tables and 4 hours for chairs, and for painting there's 2 hours for tables and 1 hour for chairs, and then the combination of those can only have so many hours available. So we want to build all of that into our constraints and our data input tables. But remember, we want to start by kind of determining what we're trying to do with our model. Okay, so my first step, I'm going to decide what are my, let me make my screen a little bit larger for you guys. Make it easier to see. Okay, so I'm going to define my decision variables. Remember, those are the changing cells. What am I looking to adjust to come up with my optimal goal, my objective? So I'm going to say T to me is going to be equal to the number of tables to produce. Remember, we want to be specific, not T equals tables, C equals chairs, because then someone looking at this might not quite understand what I'm doing. But for this, it's the number of tables to produce. And then C is going to equal the number of chairs to produce. Okay. And then I'm going to define the objective function, which is my goal. And my goal is to maximize profit. And that is when I'm going to maximize, it's equal to, I make $7 for every table I make, or sell, excuse me, plus $5 for every chair I sell. Okay. And then I want to define the constraints. Okay, so I have constraints on carpentry where 3 hours for every table plus 4 hours for every chair has to be less than or equal to 2,400. This is coming from this table right up here, guys, okay? I'm not making it up or trying to come up with it on my own. I'm just getting it from that. For every painting I have to do, I have 2 hours for every table plus 1 hour for every, struggling to get that plus sign in there, plus 1 hour for every chair, and that has to be less than or equal to 1,000. Okay. And then we had some other constraints, other limitations. I can make no more than 450 chairs, but I have to make at least 100 tables. Why is that there? Maybe management has promised an order to a company of 100 tables. So they know I have to make at least that many tables. And they know from experience that there's no way they're going to sell more than 450 chairs in a month, so they don't want to go more than that. So we're going to put that in here. So for my chairs have to be less than or equal to 450, and my table has to be greater than or equal to 100. Okay. And let's just, so I know what I'm talking about. That, like, why do I have that there? I'm just going to put, that's the max number of chairs. And this is the minimum number of tables. Again, the more notes you can leave in there, and I actually said in the PowerPoint that I would show you how to leave notes. If you didn't want to type that out there, you wanted to put a note in this cell, you could click on this cell and then come up here to insert. Never mind, come back down here, right click and insert comment. Okay, and then you can say this is the max number of chairs to produce. Okay, and then down here, go to the table, right click, insert comment, minimum number of tables to produce. Okay, and if you hover over that, you can see if I go right to that corner, it tells me my comment. So I can, if I didn't want to put it out here, I can make a comment in the cell, and the red triangle would indicate to a user that, oh, okay, I see, that's not, I get it. Okay. All right, then we have our non-negativity constraints. And we want to say that tables cannot be greater than or equal to 0, or have to be greater than or equal to 0, and chairs have to be greater than or equal to 0. And you might say, well, that seems common sense. But again, we're trying to be thorough, just because we don't want to have anything assumed in our models. Okay. And again, we'll take care of this by ensuring that we have that box clicked in our solver program. All right, let's do our data entry stuff here. So let's build the model. I'm going to have my data cells where I've got carpentry and painting. And then I also know up here the profit per each table or chair sold. So I know profit per unit. Okay. So I've got my tables and my chairs, and I've got, and again, this is coming right from this data entry box that I have up here. 3 hours of carpentry for tables and 4 hours for chairs, and then 2 hours for tables and 1 hour for chairs. And then I make $7 per table and $5 per chair. But I want to indicate to the users on my worksheet that this is actually a monetary value. So I'm going to click on my $sign so that I can show that, oh, okay, those are dollars. Okay. Remember, my data cells in my worksheet, I'm making blue. Just be consistent to whatever you're doing. Okay. All right. And then we're going to have some constraints that we're going to put into our model. And you don't have to, I don't even think the book shows you color coding this. I just like to do it just because it reminds me that I need to make sure that I'm looking at this. Okay, so my constraint says that for carpentry, I only have a maximum of 2,400 hours available. So I can have no more, greater than or equal to 2,400. Okay, and this is, I'm going to put this out here as hours available. And these two are also data entries. So this is information we would have to get from our product managers. And then I said I have no more than 1,000 hours of painting available. So painting can be less than or equal to 1,000. I don't have to use all of those hours, but I can't use more than those hours. Okay. All right. Then we need our decision variables. Again, our changing cells. And that is the units to produce. And I'm going to put those in yellow. They're yellow in my worksheet. And again, logically speaking, one looking at this would go, okay, well, that must be the tables, because that's in the tables column, and that must be the chairs. But I like to be thorough. So let's say that's the tables, and that's the chairs. Okay. And then we have our objective function. And my objective is to maximize profit, where I have that it is equal to, I make $7 for every table I sell, plus $5 for every chair I sell. Okay, oops, didn't like that. Okay, so I'm going to put that here. My total profit then would be equal to $7, click on that, times the number of tables I produce, plus $5 times the number of chairs I produce. Remember, I'm not hard coding anything in here, okay? Because if I come back into my worksheet and my profit per unit changes, it will update this formula for me automatically versus having hard coded in here and have to go back and change the formula. Okay, my objective function on my worksheets was orange, so let's make that orange. Okay, I also have to then come back up to my constraints and actually build the formula for the constraints, okay? So it is equal to the hours available for carpentry for tables times the number of units. And remember, I'm going to F4 that to hold that constant because I'm not going to change that reference, plus the hours available for chairs times the number of chairs produced. I'm going to F4 that also. So that's a good formula that I can just hit enter and drag down to the painting, because it will then do exactly what I want it to do, which is the painting hours times the number of units. Okay. Okay. We also, though, remember we had some other constraints. So this one I told you was a little bit different in that we had some other things beyond just our little table of input here. Where you put the other constraints is a decision that you would make within your worksheet. I'm going to put it down here at the bottom, and I'm going to label it as other constraints so that I know when I start using my solver, I have some more things I need to build in there. Okay. What I want to do, though, guys, is follow the same type of formatting, because think about when you went into the solver and you said add a constraint. It was like, okay, what's the constraint, which is the formula driven, right? What is it greater than or equal to, less than or equal to? And what is the total constraint? Okay, so we want to make sure we follow that same setup as I'm listing my other constraints. So I have constraints right here on tables, okay, and I'm going to follow that same format. So I'm going to skip this cell for right now, and the tables have to be greater than or equal to, so greater than or equal to 100, okay? And that is, again, the minimum number of tables. And then my chairs, let's get that for right now, have to be less than or equal to 450. And that is, okay, so I have to build this reference. So my total number of chairs, which is, or excuse me, tables, which I'm trying to figure out. So whatever I decide that units to produce, so I'm going to reference the units to produce greater than or equal to 100. And then for my chairs, total units of chairs that I produce has to be less than or equal to 450. Okay? All right. So this right here, I'm going to, because these are actually right here, guys, these are actually data entry cells. This would be information that I would need someone to provide that information and make sure that I enter it into my spreadsheet. Okay, so I think we've got everything in. Let's go ahead and work on our data solver. So data solver. And I'm going to get rid of everything that I have in here. Okay, so my objective is my total profit. My objective is to maximize by changing the units to produce, subject to the constraints. So my first constraint is the carpentry. It has to be less than or equal to the 2400. I'm going to add that. My next constraint is the painting hours. Again, less than or equal to the 1000. I'm going to add that. Now I've got my total tables, but in this case has to be greater than or equal to the 100. And then I have my total chairs less than or equal to 450. And then I say, okay. So I have my objective to maximize by changing the units to produce. I have all of my constraints. I want to make sure that I do not allow negatives and that my solving method is the simplex LP. You have all that. We're going to click solve. They found us, Excel has found a solution and I want to keep it. So I'm going to say okay. So what you can see is that I will be producing, to maximize my profit, 320 tables and 360 chairs. And you can see that that meets also my other constraints, that I have to have a minimum number of tables and a maximum number of chairs of 450. So check your solutions to that. If you're having trouble where you couldn't get your solver to work correctly or it wasn't setting up properly, the best thing you can do really, guys, is when you message me, send me your Excel file, attach your file when you're sending a message to me through Canvas inbox, because I can usually solve it pretty quickly for you and get you back on the right track. But if we're just talking about what you have in your file, it's very difficult for me to be able to provide any meaningful feedback. So if you are struggling with this one specifically or any of them, just send me your file and I'll be able to help you. Okay. All right. Last one I want to go over in this video is looking at this homework example. So what I actually did here is I went over into Connect and I just did a snip, and I've shown you this, guys, in the past, where you can just do a snip, and I just highlighted this and then put it over in my Excel worksheet so that I know what I'm working with. And I have gotten so much feedback from students that have been successful in previous classes, that have told me that, especially when we're doing our homework offline, we're doing it in Excel and then we're just putting answers into Connect. If you just have a bunch of numbers in your Excel worksheet, you don't really know what you're doing. But if you actually have the problem here and then you are solving it and then you save your Excel work, when you come back to study later on, you can see how you approach this type of problem. So it's just a suggestion that might help you. When you get into Connect, this is how Connect puts together the problems for optimization problems on solving either maximize or minimize. And I just actually chose one that was minimize. But you might look at this, and I didn't want it to be overwhelming, like, what? I didn't see anything like this. How am I going to figure this out? So I thought I would just take one, walk you through it, because then this will be the style that you're seeing when you get over into Connect. All right, same steps, okay? Let's look at what is our decision variables. And in this case, it says find the optimal solution. Again, it says find the optimal solution for the following problem. So we're trying to find the optimal values for x and y so that I can minimize c. So my decision variables are x, what is x's optimal value, and y, what is y's optimal value, okay? My objective function, and my goal is to minimize, and it's just really copying with the problem, c, so that 4x plus 12y. And define my constraints. And my constraints are these subject to. So I'm going to be subject to 3x plus 5y greater than or equal to 12, 6x plus 2y greater than or equal to 10. And then I have non-negativity constraints that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. Okay, so let's build our model. My data cells. They really don't tell us like what is x and y. In the past we've had, carpentry and painting or windows and door, whatever it is. But really I just have constraints. So I'm going to say this is constraint 1, and then I'll have constraint 2. Okay, and constraint 1 is this first one right here. 3 of the x values and 5 of the y values have to be greater than or equal to 12. 6 of the x values plus 2 of the y values have to be greater than or equal to 10. Okay? And the values, again, we don't know if it's money or the problem is very vague. So my values, in previous examples, this is where we put our profit or cost, but all we know is that it's 4 of the x's and 12 of the y's, and that's right from this minimize, okay? And so data for me is blue, so I'm going to put those all in blue, that I have them, okay? My decision variables, again, is optimum value. And my decision variables for me have been yellow. Put yellow. And then again, I put X and Y. And then I'm just going to go back and put in here my changing cells. So I have that reference. Okay. And then my objective or my goal is to minimize C, and then that's where I'm going to build this formula, okay? So that's equal to the value of x times the number of units I'm going to produce plus the value of y times the number of y units. And my objective I'm going to put in as orange. Okay, I do have other constraints, just a reminder really of my non-negativity. Both x and y have to be greater than or equal to 0. Okay, these are my constraints, my formulas here, so I'm going to be okay, so in this formula, it's equal to 3 times the number of x, hold that constant, plus the 5 times the number of y units, hold that constant. Okay, if you do that, you can drag that down to the next line too. Okay. Okay, I think I have everything. So now I'm going to put my cursor on my objective function. I'm going to go to my data ribbon, solver, and again, I'm going to get rid of these. Okay, my objective is to minimize C. So make sure you have your minimize button chosen by changing these variables. And my constraints are, clicking on that, this is greater than or equal to the 12. Add. The next constraint, again, greater than or equal to the 10. And say OK. Make sure non-negative, and you have simplex LP chosen. And we'll click solve. It says it got an answer for us. That's great. Let's keep it. And this is what we would come up with. To minimize our cost, we would actually produce 4 units of X and no units of Y. Okay? So the theory is exactly the same on what we've been working on with the other problems, guys. It's just the way it's presented in Connect for Homework might have confused some of you. So I just wanted to make sure to go over that so you had an example. That's it for my videos this week. If you have any questions, again, please reach out to me via Canvas. And once again, if you are stuck on something in your spreadsheet, it's always best just to attach that to the message you sent to me so that I can look through it and try to get you back on track. Have a great week, everyone.